All right, guys, let's go ahead and look at these multiple choice questions. The main difference is they're only answering one thing, so they're not going to be extra parts. They should be pretty straightforward, okay? A particle moves on a hyperbola, xy equals 18. What if I don't know what a hyperbola is? What if I'm like so stressed out by this question? Doesn't matter. Take a derivative, you know? We're always taking derivatives, guys. And since we're doing rate, we have dy dt, we're going to take a derivative with respect to time. So derivative of the first times the second plus the first derivative of the second equals 0 because the derivative of a constant is 0. At a certain instant, now it tells me y is 6, dy dt is 8. Beautiful. Y is 6. dy dt is 8. I have a problem, right? Because right now I have both a dx dt and an x. Okay, and it didn't give me both of those. Well, remember that if you're missing a variable, you go back to the beginning. So if this says x, y equals 18, and over here it told me y was 6, it would make sense that x would be 3. Okay, so I can actually go into here and say that x is 3, and now I can solve this pretty easily. So 6 dx dt is negative 24. 3 times 8 is 24. I subtracted it over. So dx dt is negative 4. It doesn't really tell me. Yeah, units. Okay, so what is true about x at its instant? It's decreasing or increasing. Well, it's negative, so it's decreasing by 4 units per second. Pretty straightforward. All right. Oh, we've got this rubber tubing that is maintaining its cylindrical shape as it's stretched. I really need to look at my cylinder. Boom, 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 boom. Okay. So the radius and the height are both changing. At the instant when the inner radius is 2 and the height is 20, the inner radius is decreasing at a rate of 0.1 millimeters per second. The height is increasing at a rate of 3 millimeters per second. Actually, I'll just wait and put my units at the end. Which of the following statements about the volume is true at this instant? And then there's my volume equation. Well, volume, so dv dt, let's leave the pi out. Let's go 2r dr dt times h plus r squared dh dt. And I'm going to just go ahead and plug things in. All right, 2, r is 2. dr dt is negative 0.1 and h is 20. And then I have r squared and dh dt, which is 3. I didn't leave myself a lot of room here, but okay. 2 times 2 times 20 is 80. 80 times 0.1 is 8. Right? So that's negative 8. And then 2 squared times 3 is 12. So this is pi times 4. And it is positive. Okay? So the volume is increasing by 4 pi. And then one more question here. The volume of an oddly shaped candle varies with its height using the equation. So it's giving me an equation. I'm going to go with that. The height is decreasing at a constant rate of 1 inch per hour at time equals 2. I don't know if I'll need that or not, but I'll just put it over here. At time equals 2. Okay. The height of the candle is 6 inches. Find the rate at which the volume is changing at that time. All right. Let me go ahead and put my volume equation down here. So my volume was 4h squared minus 3h plus 8. So dv dt is 8h dh dt minus 3 dh dt, and that is a constant. But like the derivative of 3h is 3, but I still have to put dHdt on it, okay? So I'm going to get 8 times 6 times -1, and then 3 times -1. So that gives me -48 and +3. So that gives me -45. The volume is decreasing by a rate of 45 cubic inches per hour. Okay? Don't forget to go back and study a cone question that we've done previously, and then you guys are good to go.